All right, calculus, here we go. We are at section 2.7, which is one of the big ones. Derivatives, hashtag yay, and rates of change. If there's one thing I really need you to understand today, it's that, that's my dog, Yogi. I think he's chasing a fly. Yesterday, in making videos, he was locked up. Because if anybody makes a movement outside, you know, whether it's the mail, Amazon, squirrel, Yogi's gonna get barking. So we're gonna give Yogi a chance because I felt bad locking him up in a bathroom for an hour and a half yesterday while we were making videos. So Yogi, you've heard it in front of everybody. This is your shot, buddy. All right, so if there's one thing that I want you to really understand today, it's that a derivative is the same thing as a rate of change. What do you also know a rate of change to be? Slope. Derivatives, rate of change, slope. All right, now we know slope of lines that are straight, So, you know, that was one of the big questions that's the earliest mathematicians have. Like, how can you figure out the slope of a curve and what does that mean? So we're going to talk about that today. The journey starts. All right, so this is section 2.7. We'll have 2 or 3 days of these notes. The tangent line to the curve y equals x. So that's the curve. Y equals f of x. F of x, the curve. At the point P, where you plug in some a for x, and then y is just f of a. So that's the point a, comma f of a. Got an x and a y. Is the line through point P with the following slope. Now, this is what a slope formula looks like. Difference of the y's, f of x is y, f of a, that's a y value. Difference of the y's over difference of the x's. All right, that's your first big formula. So write that down, highlight it. Please pause these notes whenever. I try not to make 30-minute videos for every class here. The slope is the limit as x approaches a. So we're trying to get as close as possible to that exact point. That's why x is approaching a. All right? So let's look at the curve y equals x squared and the point 1, 1. When you plug 1 in for x, you get 1 for y. And let's guess the slope of the tangent line to the curve at the point 1, 1, and that'll be our first question. So, you know, hashtag Desmos here, man. I'm giving Desmos a lot of free publicity. I think a lot of people already know of them, so they're not going to send any advertising dollars this way. Anyway, we have x squared. Here's a point 1, 1. So again, a tangent line, you know, hits that point exactly once. It doesn't cross it, bounces, just kind of like bounces off. So the tangent line would be right here. So the slope is clearly going to be positive. You know, what is the slope? So I'm asking, like, what is the rate of change at this curve at the point 1, 1? And this is clearly not a straight line, so you can see how very important this is to anything with a path of motion that is not straight. I mean, just think of anything in the sciences and in the sky. This is tremendous. All right, so what happened there? Oh, cool. If you touch it, it really highlights. That's fun. Anyway, at the point 1, 1, if I drew a tangent line, a curve like right there, a straight line. Again, I'm getting so very close. You know, from the right side, getting really close. From the left side, getting really close. That sort of deal that you kind of know of from limits. All right, so I don't know, guess. Is it slope 4? Is it 3? It's definitely positive. Let's figure out how we can find it exactly. All right, so again, we're in the limits chapter, so you'll be able to find this much quicker in chapter 3, but we got to put in the work. We need to understand that I'm trying to get as close as possible to that point 1 without actually hitting it. All right, I'm trying to get so infinitesimally close to it. Hence, harnessing the power of infinity there. Find an equation. This is example 1. Find an equation of the tangent line to the parabola y equals x squared at the point 1, 1. Point slope form to the rescue. Remember I told you in college algebra, that was maybe the first time you learned about point slope form. That point slope form was going to come in big in physics and calculus. And here we are, point slope form. So I'm going to use the formula. The slope of the tangent line is equal to the limit as x approaches a of f of x minus f of a over x minus a. Again, that is a slope formula. So f of x is x squared, a is 1, so f of 1 is 1. We know it right there. There's a, there's f of a. All right, so I have the slope of this tangent line, which is a rate of change, which is a derivative, is equal to the limit as x approaches 1 of f of x minus f of 1 over x minus 1. All right, write all that down. Yogi, I hear you growling, buddy. You're already on strike 2. The limit as x approaches 1. That's f of x, x squared, minus 1 over x minus 1. All right, again, this is f of x minus, this is f of 1, all over x minus a, x minus 1. All right, well, we know we can't plug 1 in for x. We're going to get 0 over 0. We are going to have to use the tricks we learned in section 2.4. So I need to factor x squared minus 1, and there it is. X minus 1 is a problem because within my denominator is 0. So that problem then cancels. So I have the limit as x approaches 1 of x plus 1. Now I can plug 1 in for x. And that equals 2, so my slope is 2. Right there when we looked and we said, hey, what's the slope of the tangent line? If I made a tangent line right there, what would the slope be? That slope is 2. All right, so that is the rate of change of the curve at 1, 1. So that is the derivative of that curve at the point 1, 1. That's pretty cool. So we're going to use point slope form, which is y minus the y value is equal to the slope times x minus the x value. Well, you know the x value and the y value, and the slope is 2. So we say y minus 1 is equal to 2 times x minus 1, and that is it. Find the equation of the tangent line to the parabola, to the curve at the given points. It is that right there. All right, that is our first one. So let's continue with this on the next page. I think we have 6 examples. I'll try to do, 6 or 7 examples each day, and I think that'll be enough. Today we have them on a little bit on the easier side. So it says find an equation of the tangent line to the curve at the given point. Here's the curve. Again, pause this whenever you need to. F of x is equal to 4x minus 3x squared. That's the curve. And the point is 2, negative 4. Again, we are using this slope formula. The limit as x approaches a of f of x minus f of a all over x minus a. That is what we're using. All right, so we got the slope is equal to the limit as x approaches what? X is approaching 2 of f of x, which is 4x minus 3x squared, minus a negative 4. You're subtracting negative 4, which means you're adding 4. All right, so now this is a problem. We can't have a negative leading coefficients when I have a quadratic. So factor out the negative up top. Now, folks, be smart here. What has to be a factor of this above? If you're not, great at factoring, again, I don't need to know. You can mask that a little bit by knowing x minus 2 has to be a factor, all right? It has to be canceled out, or we're in a 0 over 0 situation. This curve definitely, this is another parabola here, and I can actually, while I'm talking, I'll just do this one more time. I'm going to write in 4x minus 3x squared. What are we? We're at the point 2 at negative 4. I'm going to zoom out a little bit. So here's what's going on. This is an upside down parabola, makes the igloo. And the point 2, negative 4 is right there. So it's got a negative, the tangent line would have a negative slope. So I got to get an answer. I can't get something over 0. I can't get 0 over 0. So this x minus 2 is going to be factored out. Okay, so I'm just going to put, again, you have a negative sign on the outside because I factor out the negative. The negative sign's on the outside. X minus 2 is going to be a factor. And the other one, well, if that's x, the other one has to be 3x. If that's a negative 2 times a positive 2 gives you negative 4. And that's negative 6x. Positive 2x gives you negative 4x. It's been factored. All right, so then what's going to cancel the x minus 2's? leaving you with the limit as x approaches 2 of the opposite of 3x plus 2. Now I can plug 2 in for x. Plug 2 in for x. You got negative 8. Negative 8 is the slope. Negative 8 is the slope. All right, that is awesome. And we knew it was going to be negative, right? If the curve was going down, it was decreasing. So when a function's increasing, I get a positive slope, positive derivative. And when the function's decreasing, I get a negative derivative. That sounds like something we should remember. So y minus the y value is equal to the slope times x minus the x value. And we got that. Again, this is all from college algebra. That part isn't. But we're just building upon some things we know. There you go. That is my equation of the tangent line. The derivative at the point 2, -4 is -8. The rate of change is -8 at that point. Really good stuff there. All right, let's take a look here at number 11. The same deal. Find an equation of the tangent line to the curve. We got a cubic here. X cubed minus 4x plus 8 at the point -2, 8. That is the point -2, 8. So again, I'm using the slope is equal to the limit as x approaches a of f of x minus f of a over x minus a. Yes, you'll have to remember that for a quiz. When I'm back, you have to know that for a quiz. Okay, that is simply a slope formula. Difference of the y's over difference of the x's. You will have to know that one. That's not given, so start memorizing that. Difference of the y's, f of x minus f of a over x minus a. And x has to approach where it's going, -2. So I have f of x up top minus f of a. It's probably a good idea to put that in parentheses. I'm going to give you a different formula. For tomorrow's notes, that involves f of x plus h. You've seen that before. And f of x. It's good to have that in parentheses. All right, look at that. The 8's cancel. This was pretty interesting. That's what I'm left with. Ooh, so a is a -2, so you have x minus a -2, so it's x plus 2 down below. Factor out the x they have in common. X squared, again, this x plus 2 is an issue, so a factor up top has to be x plus 2. What do you got here? This factors be x minus 2, x plus 2, which we have up here. And the x plus 2's are gonna what? Cancel. So you have the limit as x approaches -2 of x times x minus 2. Now I can plug -2 in for x there, and the slope is 8. So you have y minus the y value is equal to the slope times x minus the -2, which is x plus 2. And that is our second one there. Again, pause when you need to. We'll try to explain, but I can't make them 40-minute videos. All right? And then come back and watch these. These will be on the interwebs forever. Find an equation of the tangent line to the curve y equals the square root of x. You have one on your homework like this, when x is equal to 9. So we're going to use the slope is equal to the limits as x approaches what? X approaches 9 of f of x minus, what's f of a? Well, just plug 9 in for x. F of 9 is 3, so minus 3 over x minus, what's it approaching? It is approaching 9. So we've seen these before. You had a bunch of these in your last homework set. I'm going to multiply by the conjugates of this up top. Multiply top and bottom by root x plus 3. That's going to give you x minus 9. Look at that. You got an x minus 9 south times the conjugate. Leave the conjugate there. And as we know, Yogi, that was my pen. At ease. As we know, the x minus 9s are going to cancel. Leaving you with the 1 over the conjugates. And you're going to plug 9 in for x. Root 9 is 3. 3 plus 3 is 6. And that is the slope. Cool, the slope is 1/6. The rate of change is 6. So y minus the y value, which I had to find, is equal to the slope times x minus the x value. This is great. We got 2 more here on the last page. I'm going to tell you which ones you can definitely handle for your homework and which one you might want to wait until Thursday's notes to really focus on those. Find an equation of the tangent line to the curve at the given point. Y is 2x to the third minus 3x squared plus 5x plus 1 at the point 1, 5. Okay, so again, I have the slope is equal to the limits. The limit as x approaches 1. Sorry, I get emails and different messages while I'm making that. That was a funny one. So here's f of x minus f of a. When I plug 1 in for x, I get 5 all over x minus a. F of x minus f of a over x minus a. 1 minus 5 is a negative 4. Uh-oh. How in the world is that top going to factor? Well, folks, we know that x minus 1 has to be a factor. I've got a polynomial here. We're taking this back to college algebra, chapter 6, synthetic division. You knew synthetic division was coming back. So here's what I know. I want to divide this polynomial by x minus 1. That means I set what I'm dividing by equal to 0. I want to know, is 1 a solution to this? It is. So I put a 2 for 2x to the third, a negative 3 for negative 3x squared, a 5 for the 5x, and a negative 4 for the constant negative 4. I always bring down this 2 because really I'm doing 2x to the third divided by a single x with 2 divided by 1, 2. So then I do what's in this cubby. I multiply. 1 times 2 is 2, and then I add the columns. Negative 3 plus 2 is a negative 1. I do 1 times negative 1, negative 1. Then I add them together, 4. I do 1 times 4, 4. I add them together, and I better get 0. If I don't get 0, which I didn't, on number 6, I made a boo-boo. I forgot about something. I've been incorrect somewhere. Maybe I have to add in a 0 because I skipped a term. We'll talk about it later. But boom, I divided it out. So you don't need to show any other canceling. This synthetic division shows that you have divided the x minus 1 out. And here's what you're left with is 2. If I divide x to the third by x, I'm left with x to the second. So this is for 2x squared minus x plus 4. That's what the 2 and the negative 1 and the 4 mean. The limit as x approaches 1 of 2x squared minus x plus 4. Now I can plug 1 in for x, and I get 3 for my slope. So y minus the y value is equal to the slope times x minus the x value. I've got that right here. Excellent. Synthetic division will be in play on some of these. Please know how to do it. And we're going to finish here with number 6. Find an equation of the tangent line to the curve y is equal to 3x to the fourth minus 2x squared plus 3x. Did I make 2 boo-boos? Well, we're gonna have to do a little readjustment here because I made another boo-boo over here. All right, so here's what we got. We got the limit. This is fine. The limit as x goes to negative 1 of f of x minus f of a all over x minus a. A lot of subtracting negatives here, so this is how it cleans up. All right, so again, I know that x plus 1 has to be a factor. I said x plus 1 equal to 0. Negative 1 goes in the cubby. Now, be careful. This is a 3x to the fourth, so 3 goes there. There is no x to the third. You can see I skipped that. I didn't put a 0. There is no x to the third, so you have to put a 0. All right. No, I didn't make it. Nope, I was looking at something. I did not make a boo. We're all good. Negative 2 for negative 2x squared. A 3 for 3x and 2 for the constant. Make sure that 0 is there for no x to the third. I bring down the 3 because 3 divided by 1 is 3. Negative 3 times 1 is a negative 3. I add them up. Negative 3 times negative 3 is a positive 3. I add them up. Negative 1 times 1 is a negative 1. I'm sorry, negative 1 times, negative 1 times 1 is a negative 1. I add them up. Negative 1 times 2 is a negative 2. I add them up. I get 0, which means x plus 1 is a factor. It divided out cleanly. What does that 3 mean? Well, it's x to the fourth divided by x, so that is x to the third. That is 3x to the third minus 3x squared plus x plus 2. Now I can plug negative 1 in for x. Negative 5 is equal to the slope. Y minus a negative 2 is y plus 2 is equal to the slope negative 5 times x minus a negative 1, which is x plus 1. That is the equation of my tangent line to the curve. At negative 1, at negative 2, the curve has a slope of negative 5. The rate of change is negative 5. The derivative at that exact point is negative 5. That's everything we can gather from that question. And that is fantastic. All right, folks. Let's take a look at this homework set, which I told you you're going to submit to me by, oh, what's it? What is it? Was it Sunday by midnight? Or 9 p.m.? Don't stay up to midnight. Please submit it earlier. Again, I helped you with number 3 yesterday. This entire first page we can handle. Again, we know how to approximate this. If you write small enough, you can write it on this document. We should be all right. Should be all right. You know, then the next page, be very careful. I did an example like that. Be very careful on that one. Again, we can approximate that one. We know what the most important term up top and down below is. Be very careful, though. On that one, you got the root on top and at bottom. You know how to factor 10. You know how to approximate 9. And 9 is basically the same thing as 6. Okay. Then we get to 12. The intermediate value theorem could not be easier. That was in the section 2.5 notes. Now 13, I'd probably back off of 13 for now. I'm going to help you with 13, something like it tomorrow. But you had one today with the square root. That was example 4. Man, that looks very, very similar to number 14. I'd handle 14 now. Then let's go to 15, all of 15. I think we're good to go on those. I think you're ready. Might have to do a little synthetic division on A and C. Definitely C. B should be good to go. So all of 15, let's handle that. Again, start on your homework early and often. Please do not wait to the end. 16, and we did plenty of ones like 16. You can just factor 17, and boom, 18. We've seen that one a lot. It's literally almost like number 2. That's pretty funny. Okay. All right, folks. Handle your homework. Let's get off to a good start. I will have another video and just more things for the next week for you tomorrow. This is Yak Math Videos signing out.